Hello, my dear students. Welcome to my YouTube channel that's Concepts of Chemistry. So, today's topic of the lecture is Modified Dalton Atomic Theory. In the previous video, we have done the Dalton Atomic Theory with the limitations. So, according to limitations, the Dalton Atomic Theory has been modified. So, first of all, I have written the previous postulate so that I can make you understand better the modified postulates. So, let us start with the very first postulate. The very first postulate of the the previous first postulate was the matter is made up of extremely small indivisible particle called atoms. So now it is modified as atom is no longer considered indivisible. The atom has a very complex structure. Atom has a complex structure. It is made up of subatomic particles. It is made up of subatomic particles, that is electrons, protons, and neutrons. In the further topics, the upcoming videos, I will make you understand the arrangement of electrons, protons, and the neutrons in the atoms. So, the first point says that the atom is no longer considered indivisible. The atom has a complex structure and it is made up of subatomic particles, that is electrons, protons, and neutrons. So, this is the first point. Now, let's talk about the second point. The atoms of same element are identical in all respects, that is size, shape, and mass. This is the previous postulate. The second one, the atoms of same element are identical in all respects, that is size, shape, and mass. So it has been modified as the atoms of same element may have different atomic masses. Atoms of same elements may have different atomic masses, and we call that atoms isotopes. So let's define isotopes. Atoms of same element having same atomic number but different mass number. Let me give you some examples. I have written hydrogen, hydrogen, hydrogen. The atomic number 1, 1, and the 1. The If you are having any element, let it be X, you always write atomic number at the base towards left and mass number at the top towards left. So, first of all, I have written the atomic number of hydrogen 1 along each edge. Now, the first one, the mass is 1 and it is called protium. The mass number is 2 and it is called deuterium. It's 3 and it's called tritium. So these are different forms of hydrogen with different masses. The first one, when the mass number is 1, it's protium. When it's 2, it's deuterium. And it's 3, it's tritium. Now let's come back to previous postulates again. Now let's talk about the third postulate. Hold on. I can give you some more examples also. For example, I'm taking carbon. The atomic number is 6 and 6. It can be, mass number can be 12 or it can also be a 14. Let me give you another example also. I'm taking example of chlorine and chlorine. The atomic number is 17 and that's also 17. Here the mass number, the first one the mass number is 35 and this 37. Okay, so now let's come back to the previous postulates again and let's see the third point what is saying. The atoms of different elements have different size, shape and mass. Saying that the atoms of different elements have different sizes, shapes and masses. Now let's come back to again modified postulates. I'm giving you the third modified postulate. It says that atoms of different elements may have same atomic masses. What the previous postulate said, that atoms of different elements always have different masses, but now the atoms of different elements may have same atomic masses. That's the modified one. Let me give you an example. I'm writing calcium over here and argon over here. The atomic number of calcium is 20, the atomic number of argon is 18. So it confirms they are having the different atomic numbers. So there's the different elements, but their mass numbers. The calcium has 40 and argon also is 40. So it's an example where the two different elements have same atomic masses. Now let's talk about the fourth one. Now fourth postulate, the previous postulate, fourth one. When atoms combine with one another to form molecules, they always do so, or they always combine in simple whole number ratio. That's the previous postulate. Now let's talk about its modified form of postulate, the fourth one. The ratio in which different atoms combine with one another may be fixed or integral, but not always be simple. So the ratio in which, I'm writing it down, the ratio in which different atoms combine. The ratio in which different atoms combine with one another may be fixed or integral. May be fixed and integral, but may not always be simple. Importantly, but may not always be simple. Let me give you an example. When the combining atoms does not have a simple ratio, they are called as non-stoichiometric compounds. When they have simple ratios, then they are called stoichiometric compounds. Here I'm talking about the compounds which are not having simple ratios. So they are called non stoichiometric compounds. What does it stands for? When combining atoms in a compound does not have simple whole number ratio with one another. In upcoming videos of mine, I'm going to make you study the periodic table, and there I will tell you about the transition metals or the d block elements. So it's a characteristic of d block elements that they always form non-stoichiometric compounds. That's the transition metals. The transition metals always form non-stoichiometric compounds. Uh, Let me give you an example. Ytterbium hydride. Here ratio is 1 is to 2.55. So you can easily see that the ratio is not whole number. So it's a non-stoichiometric compound. Another example is titanium hydride. Its ratio is 1 is to 1.8. Again, it's not a whole number ratio. It's not a simple ratio. Another example is like lanthanum hydride. Here ratio is again not whole numbers, 1 is to 2.87. So you can easily see that the ratio is not whole numbers. It's a non-stoichiometric compound. So the ratio in which different atoms combine with one another may be fixed and integral, but may not be always simple. So I have given you the example. So let us come at the fifth point or previous postulates. So the previous postulate, the fifth point is saying that atom is the smallest particle that take parts in a chemical reaction. No, as atom is composed of subatomic particle, which I have given you the in the very first postulate. The electrons are the smallest particle that take parts in a chemical reaction. So that's the modified postulate. Let me write this thing. The fifth modified postulate from the previous one states that in an atom, comma, electrons is the smallest particles that take parts that takes part in a chemical reaction. So that's the fifth point that have been modified. The previous postulate says that atom is the smallest particle that take part in a chemical reaction, but now it states that electrons is the smallest particle of atom that take parts in a chemical reaction. So let's come back to the previous postulate. So what's the last postulate? The sixth one states that the atom can neither be created nor destroyed. But this point have been modified. I am writing over here the sixth point. They were saying that atom is not neither created nor destroyed, but now atom is no longer indestructible. No longer indestructible. That is, by carrying out nuclear reactions, by carrying out nuclear reactions, nuclear reactions, we can break we can break heavier atoms to lighter atoms. For example, I'm taking the heavier atom, the radioactive atom, the uranium. Its atomic number is 92 and its mass number is 235. When we have an attack of alpha particle on uranium whose mass number is mass number is 4 and atomic number is 2, the uranium is broken down to plutonium, where mass number is 239, but the atomic number decreases by 2, it's 90. So that means the heavier atom, which is a uranium, it is broken down by the nuclear reaction. What does nuclear reaction stands for? Where electrons are not involving, where the protons and neutrons which are present in nucleus, they are involving. So uranium is broken down to plutonium, where the atomic number comes out to be 90. So this is the process of conversion of element. So in chemistry, the process of interconversion of element through changes in atomic nuclei is called transmutation. I am mentioning you here that the process of interconversion of elements, the process of interconversion of elements through changes in atomic nuclei, through changes in atomic nuclei is called transmutation, is called transmutation. So these all were the modified points of Dalton atomic theory, which I have discussed. Firstly, in this video, I have discussed you about the previous postulates, and then I have given you the modified postulates with respect to the previous postulates. So, my dear students, I hope you understood the today's lecture. I have given my phone number on the thumbnail of this lecture. So, if any one of you wants to book a paid one-to-one online class to clear doubts, contact me on my phone number. Please like, subscribe, and share my channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.